All right, good morning and welcome. I appreciate you guys tuning in. I'm going to do a quick little video introducing you guys to antiderivatives, which are also known as indefinite integrals. So you can use those terms interchangeably. So here's what you know so far. If you have a function like x squared, you become pretty familiar with taking the derivative. And you've done this with a ton of different functions, whether it been polynomials or trig functions. You've had some practice doing that. Antiderivatives go the other direction. Technically, they're the inverses of derivatives. So, for instance, if you were given the derivative, and say the derivative was 3x squared, and you were asked to find f of x, find the original. The idea is what function out there gives this as a derivative, and it just requires you to kind of use what you've learned backwards. And so this one, kind of starting with the basic one, the antiderivative would be x cubed, because again, the derivative of x cubed is 3x squared. This process of finding that value is known as taking the antiderivative. And there's actually a symbol for it. So let's take a look at the symbol. Kind of fun to look at. So if I have something like this, we always have to have what's called a differential. We'll get into that more lately. But for now, you can think of that we're taking the, antiderivative with respect, can't even spell, antiderivative with respect to x. Instead of having to write it like this is the symbol, this squiggly line. This is the symbol that says, hey, I want you to work backwards. I want you to take the antiderivative. So a couple more examples right here, if we get black going. The idea is we know the derivative of x squared is 2x, and the antiderivative would have to be a cubic. But you also have to balance out the coefficient. And again, if I kind of check this, the derivative would be, 3 times 1/3 x squared, and those cancel out. The derivative of 2x would be x squared. And then this introduces me to my last thing about introduction to antiderivatives, is that every antiderivative is going to have this thing called a plus c, or a constant. That's what the c stands for. Do a quick another example here. This would be 1/5 x to the 5th plus c. The idea is that with the c is that there's this extra constant, because you guys know that the derivative, of a constant is 0. So the c is just reminding everybody that, yeah, there could be a constant in there that's attached to this function. All right, let's do a couple other ones. And then just take some practice. It's definitely a weird way of thinking about it. So let's just do a couple quick ones. If I ask you for the antiderivative of cosine, also known as the indefinite integral, this would just be equal to sine x plus c. Got to keep your brain organized, because again, why is this true? Because the derivative of sine is cosine. Again, we have this kind of a loop happening. But if I go, what's the derivative, what's the antiderivative of sine x? Your brain might say, oh, it's cosine, but the derivative of sine is cosine, but the antiderivative would be negative cosine. Again, because the derivative of negative cosine is negative along for the ride, negative sign, and the negatives would cancel out. So you got that kind of thing happening. All right, it gets a little bit trickier. Here we go. What if we do the antiderivative of cosine 2x dx? So now if you think about this, you kind of have this chain rule type problem, meaning that a good first guess would be that the antiderivative is, sine of 2x. That's my guess. But if I check it, the derivative, again, you're not going to have to write this every time. I'm checking it in real time. The derivative would be cosine 2x. Wonderful. But then you have an extra times 2. So you're going to have to kind of think about accommodating those extra constants. So again, this is not precise. Let me rewrite it. The integral of cosine 2x would be sine 2x, but then I know there's going to be an extra 2, so I need to balance it out with a constant. Similar to up here, where this power rule, if you know that you're going to take the integral of this or something, you're saying, okay, I know it's got to be 1 degree higher because we're doing integrals, but then you're balancing it out with a reciprocal. You're balancing it out with a constant. All right, one last example, because then I like to keep these videos short. So here's about as weird as it gets for this intro. And again, this is just an intro because we're only, 4 or 5 weeks into the year. And then we'll spend a ton of time getting really good at these as we get better. So let's say we have something like this. One way to do this integral would be to expand it out. Expand it out into, 4 terms, because you got the binomial theorem, and then take the integral, take the antiderivative of each term separately. But that can be a lot of work. So what if we do this? The antiderivative is going to be, again, power rule backwards. We have this 4 and this 1/4. And then we know from my attempts to preach to you about the argument being carried through, right, along for the ride. This would be a decent first guess. But again, if you check it, right, mental math, the 4 comes up to cancel. But then you'd have an extra times 2 from the chain rule. And the original question doesn't have that 2 in it. So you're going to need to balance out that extra constant with an extra times 2. Just to recap, this 1/4 comes from this. This 1/2 comes from this. So how would you see it appear on an AP test? In the answer, you'd see a 1/8. And then don't forget your plus C. So this is the answer to this. How are we doing on time? I don't know. I haven't done this in a little while. All right, one last one to get you going. You can pause these and look at them, hopefully, if you need to. But like if I had a 5x plus, 2 to the 9th, the answer is going to be 5x plus 2. We have a 10th and a 1/10. And then we're going to have an extra 1/5. Check it. Nice thing about antiderivatives is you can always check them by taking the derivative. So I think the answer is this. And if you check it, you'll have like a 10/50ths. And I'm just checking to the 9th times 5. And you'll see that these all cancel. And you're back here. All right. hopefully you got a little bit out of this. I appreciate you watching. I know we're in a weird time. Stay safe, and I look forward to seeing you guys soon. Thank you.